The role of an engineer is demonstrated in a steel domestic shed design. In order to produce the steel framing, calculations of forces are required to size members and are arranged economically to transfer loads to the foundations. In conjunction with an architect, drawings are produced for pricing, fabrication, and finally construction. These documents may be used for checking the structure's capacity for future alterations and additions. To begin the design process, forces acting on the structure need to be considered. These forces translate into loads on the building and its structure. The loads are categorized as dead loads and live loads. Dead loads include the building itself, including the structure, roof, floors, cladding, etc. Basically, the permanent attributes of a building. Live loads encapsulate all dynamic forces imposed on a building, including wind, snow, earthquake, static liquid pressure, groundwater, rainwater ponding, people, furniture, storage, traffic, construction. Wind load calculations are complex and require the use of AS 4055 for housing and AS 1170.2 for all other structures. The Australian standard is used to establish a wind classification, taking into account its geographic region, terrain category, shielding from neighbours, objects, and its topographic surrounds. The result is a wind classification N1 to N6 for non-cyclonic and C1 to C4 for cyclonic regions that represent design wind gust speeds. The wind gust speed is factored by a coefficient to produce a pressure used as the design wind load on a building. The pressure can be described as positive, meaning a force applied directly to an object, or negative, like suction as it passes over an object. The structural member design process begins with a preliminary framing plan of every level, including columns. The intention is to provide a logical layout that suits the architect and client whilst achieving an efficient structural system. Starting with the roof, sheeting is selected and a purlin size assumed and space to suit. Loads are calculated, including wind action, which has both a positive and negative effect. Load combinations are checked and the assumed purlin either passes or the purlin design process begins again with a new purlin size until the suitable member is found. The next member in the load path is the rafter, which is considered a beam as far as design is involved. Again, dead and live loads are established, load combinations considered, tributary area calculated, and the moment and shear capacities calculated to select the steel member. Deflection of this member is calculated and should comply with AS 1170.2, Table C for the maximum allowable deflections. Column design follows a similar process with dead and live loads, load combinations, and tributary areas calculated to establish an axial load. A steel column is selected using axial compression tables and its self-weight added. It is recalculated to ensure the selected column still has capacity. Our domestic shed has been designed from roof to footings by establishing forces which act on the structure. The structure is designed to withstand these forces and carry its own weight and varying imposed loads. The forces are transmitted down a path of beams, columns, and walls to the footings as loads. Loads are calculated using equations and Australian standards, and manuals and manufacturers' specifications assist in the selecting the appropriate steel members.